Okay, warm-ups that are a great test review warm-up. I say great, they cover the basics, right? This isn't anything crazy on these. If you're working these at home, I'd pause and try to do them, and then come back and watch me work them. Again, these are very straightforward, so I hope these were easy for you, because there's nothing crazy about any of these. These are kind of the normal ones, and the main point of this warm-up is to just make sure we know how to set up the different types of problems. Like I said earlier, it's easy when we're doing all inequalities to get in the habit of to know to do that process. When we're doing all absolute value equations, to know that process. When we're doing absolute value inequalities, to know that process. But when we shuffle them all up, are we okay? Well, let's find out. So subtract 7 from both sides, we get 12. Divide both sides by 3, you get 4. X is greater than 4. Why didn't I ever split that up and worry about flipping signs and changing things around? It's not absolute value. Absolute value leads to the split up, leads to the break up into two separate pieces. This one had no absolute value, so just work it like normal. So one mistake people will do is overdo things and pretend that's absolute value and end up splitting it up. The other mistake is when it is absolute value and not splitting it up. So you can overdo it or you can underdo it. Hopefully it's a just right situation. Interval notation and number line. I didn't say that on here, but that's how we've been doing all of them. So if there's 4, open circle, greater than 4. So there's the picture. So parentheses, 4 to infinity. Solve it, graph it, interval notation. All right, number 2 is maybe a little bit weird because maybe it's the result of an absolute value problem because it's already split up. But whatever, we'll just solve the 2 separately. And for an OR problem, are we looking for anything that's shaded or are we looking for the overlap? Anything. Either or as opposed to overlap and. So anything that's shaded will be part of my answer solution here. So let's add 5 to both sides. Divide by 2. So x is less than negative 2. Or subtract 7 from both sides. Oh, I'm going to get a fraction here, but that's okay. X is greater than 5/3. Usually the fractions don't show up till the end, and we're done with it, so it shouldn't be a big deal that we get a fraction, because there's nothing more to do with it. That's our final answer. Okay. Especially when one number is negative and one number is positive, then we really don't have to worry about, how big is 5/3? Well, I don't know. It's bigger than negative 2, so no big deal. Less than or equal to, so closed circle at negative 2, open circle at 5/3. And we're not looking for the overlap, we're just looking for where anything is shaded. So it'll take 2 statements to catch all of that. Negative infinity to negative 2, bracket, union, 5/3 to infinity with the parentheses. Again, it's a huge deal that it was an OR problem. What if that had been an AND problem? If we had changed one thing about this problem and this had said AND instead, what would the solution be? No solution, because there wouldn't be an overlap. So yes, that word in there is a big deal because or led to the 2 pieces of the solution, and would have been no solutions at all. Number 3, how did I know right away that this wasn't going to be an interval notation problem? Yeah, it's an equality, so at most I'm going to get 2 answers. I'm not going to get a range of answers. I'm probably going to get 2. Maybe one doesn't work, maybe none of them work, but at most 2 answers. Let's see. Limited on space. So 2 steps at once. I'm going to add 3 to get 18, and then divide by 2 and get 9. Now, I know the next step is to split it up. How do I know that? What's the giveaway that this is a split it up problem? Absolute value. Absolute value, you're going to end up splitting it up. 2x minus 5 equals 9. First one, drop the absolute value bars, and that's it. The second one, 2x minus 5. How do I change things up on this one? Equals negative 9. So that means doing two steps at once here. Add 5, I get 14. Divide by 2, I get 7. Add 5, I get negative 4. Divide by 2, I get negative 2. But what do I need to be careful about with absolute value equations? I got to check, because sometimes weird things happen. It's mostly when there's a variable outside the absolute value bars, but let's check just to make sure. So 2 times 7 minus 5 minus 3 equals 15. So 14 minus 5 is 9, times 2 is 18, 18 minus 3 is 15. So that one worked. X equals negative 2. A lot of negatives in this one, so I need to be extra careful. 2 times negative 2 is negative 4. Minus 5 is negative 9. I think people make the mistake because they stop here. They stop showing their work right here. Is this one going to work? Yes. Yeah. Because what's the absolute value of negative 9? 9. I think that's where people mess up. I think they get that, they see it, and they're like, ooh, negative 18 minus 3. But no, that's positive 9 times 2 is 18. Minus 3 is 15, so we're good. And then lastly, let's see, big picture, it's absolute value inequality. So I know eventually I'm going to split this up. Right now I think this is a less than problem, but I don't really know that until I get the absolute value thing by itself. So subtract the 1 over, divide by 3. Now I know that this is a less than the problem. So I know it's going to be an and. And means overlap. I need both things to be true. The first one is the easy one. Just drop the absolute value bars. X plus 3 less than or equal to 7. The next one, what do I do to get the next inequality? Don't change anything with the inequality stuff or the absolute value stuff. Change both signs. So this will be greater than or equal to negative 7. Change both signs. I think I'm up to like 30, the total number of times I've written change both signs in the past week. I hope it doesn't go any higher as I'm grading your test, because that will mean you didn't do it and I'm reminding you to do it. Subtract 3, so x is less than or equal to 4, and x is greater than or equal to negative 10. Some of you could get the number line, the inequality or the interval notation, just looking at that and thinking about what's going on. I want the graph anyway, because that helps you figure out what the solution is. So greater than or equal to negative 10, less than or equal to positive 4, and I want the overlap, so that's the stuff in the middle. So negative 10 to 4. Okay, kind of breeze through those in 9 minutes, 10 minutes. Questions on any of those? I hesitate to ask, but I hope that felt pretty straightforward. You know there's some weird cases that we get into, but as long as you know the rules, those will kind of take care of themselves. We talked about one of the cases of you're looking for an overlap, but there is no overlap. That's one of the weird ones. Ben?
What if you get like an OR question for the overlap thing?
Okay, so if this had been So like, if this was our graph,
Yeah,
but it had been an OR problem.
yeah.
Yeah, that's the other weird solution. So if this graph had been an OR problem, OR meaning anything that's shaded, so what part of that number line is shaded? Well, that's where the overlap is, but you said we're not looking for the overlap. We're looking for where anything is shaded.
So negative.
Good. There's the pink. There's the green. If this was an OR problem, OR means anything that's shaded, so negative infinity to infinity. Crazy. But those are the two crazy types, the nothing and the everything. So if you're looking for an overlap and there is no overlap, then it's nothing. If it's an OR problem and everything is shaded, well then negative infinity to infinity. The crazy ones you sometimes get before you get to the picture, meaning if I had absolute value of x minus 3 is greater than negative 2. So it's the negatives that sometimes lead to the weird stuff. Is this going to be an everything or a nothing problem? Well, what's the absolute value? What type of number does absolute value give me? Positive. When is a positive number greater than negative 2? Always. So this would be an everything problem. So don't just see the negatives and be like, oh, that doesn't work. Like, no, think through what's happening. A positive number greater than negative 2? Yeah, that's always true. So sometimes you can catch the crazy cases before you even get to the graphing stage.